In physics, it's very important to talk about percent error. When we have some measurements and we find the error of that measurement, it's very important to compare the error with the actual value of that quantity to get some sense. Let me give you some example. Imagine we know the error of some lens measurement is equal to 0.5 meter. So this error itself doesn't tell us anything about the precision of that measurements. But if I know the actual value of the quantity measured, then I can see how precise was that measurement. For example, if I'm talking about the length of the table I have here, 0.5 meter error would be a big error because the length of this table might be something about like 2 meters. That's why 0.5 meter error would be a huge error. But if I talk about the radius of Earth, which is 6,400 kilometers, so in that measurement, 0.5 meter is totally negligible, and that's very small amount of error. As a result, we need to know how big is the error compared to the actual value of the quantity. Percent error gives us that sense. We can define percent error as theoretical value minus experimental value divided by the theoretical value. Theoretical value is what we expect to get, and experimental value is what we actually measure in the measurement or in the experiment. And if we look at this number and put it in the absolute value to get a positive number and multiply the result by 100, we can get the percent error. If you like, we can call what we have on the numerator just error or absolute error. And when I divide absolute error by the theoretical value or what we expect to get, we get a percentage error or percent error.